Yep, that is correct. Woo! Good job. So that's number 13. Good. Good job. That's number 13. Let's see here. So number 15, you are going to have to get everything to the other side first, okay? So I'm going to go ahead and add 14x to this side. Get everything to the other side. Isolate the 0. Get the 0 on the right, everything else on the left. So we add that, so that's less than or equal to 0. Good, that's what we wanted. And then we have x cubed plus 9x squared plus 14x. Oh man, how can we factor that? Well, they all have an x in common that we could pull out. So that is going to be one of our factors at 0. So we pull that x out, we get x squared plus 9x plus 14, pulling out the x's there. Can 14 factor? It can factor into 2 and 7, way-oh. Plus and plus, way-oh. So now we have an x equals 0. We have an x plus 2 that becomes an x equals negative 2. And then we also have a negative 7. Set each one equal to 0. Pause me. Try this one on your own. Come on. Try it on your own. So our multiplicities are all 1, 1, and 1, which means that all 3 of them are going to cross through, right? Cross through, cross through, cross through, cross through, cross through. Okay, so then we do our number line. Pause me. Try it on your own. Come on. You just copy it, you're going to fail the test. You got to do it on your own. So I see here actually that 0 is over here, and maybe negative 7 is way over there. Ooh, less than equal to. That means what? Open hole or close hole? Let me see it. Less than or equal to. So it is a closed hole. Good. So we have a closed hole, negative 7, and a negative 2, and it's 0, because it equals 0 when you plug those in. Way-oh. Okay, so what's our end behavior? Well, the highest power was x to the 3rd power, and it's positive. So that means that the end behavior is going to be what? So the end behavior is going to be down and then up. Do you remember? Down, then up. Good. So we draw an arrow down and we draw an arrow up. Good. So then, good, good, good. So now we're going to cross through, cross through, cross through. So our y-axis is actually here, and our y-intercept is actually on 0. Okay, ready? So we're going to cross through, and cross through. Nice. So now it asks for all numbers less than or equal to 0. What does less than or equal to 0 mean? All y values, right? We want all the y values that are below the x-axis. That's the x-axis, that's the y-axis. So below the x-axis. Okay, so which ones are below? Which ones are below? Well, if you notice here, this is below, and this is below. So those are where all the solutions are less than or equal to the x-axis there. So this is going to keep going forever, so our x values are going to keep going forever this direction. So that's going to be negative infinity until we hit the what? Then it goes positive, then changes to positive. The what? The 7. And so we do bracket or parenthesis? Do you remember? It's less than or equal to, so we do brackets. And union with, we're positive, we're positive, we're positive until, oh, we hit a 2. And so bracket, because it's equal, less than or equal to, negative 2 to 0, bracket. And so there's all our solutions that are below the x-axis, which is negative solutions. Way-oh. Okay, here we go, 17. So determine whether the function is odd, even, or neither. So basically, it has to rotate and flip if it's going to be odd. So an example of that would just be your regular old graph like this, maybe, that hits here and here. Yeah, so that can rotate. If that can rotate around the origin, let's show you that if it lets me. Why won't it let me? So here we go. We're going to just go ahead and group that together. Here we go. Let's try it. Group that together. Okay, will it rotate around the origin? That didn't do what I wanted to do, but yeah, it does, but my graph is terrible. Okay, so this one does not, right? This one does not rotate around the origin, because when you turn it, it doesn't quite match up where the origin is. I feel like I'm rotating it, but it's not doing it right. The origin is here, smartboard, right? It's there. Let's try that again. Why isn't it rotating around the origin? It's doing it right there. Anyways, yeah, for some reason it's rotating it there. So that's going to rotate, basically, and as that rotates, yeah, you're going to end up up here. And so it's not going to match. And since it doesn't match, then we say neither. Let me say neither. What do you think about this one? Ooh. So this one does flip, doesn't it? So if you flip this one to the right or to the left, boom, look, it's the same thing. So that means it's even, right? And what would an odd graph look like? What would an odd graph look like? So an odd graph would be like this, and then it rotates. Let me show it to you if it works right. So kind of like this, right? There's an odd function. And so what we mean by odd is that it like rotates itself, and it stay there. It did it. That's odd. See how you rotate it and it looks the same? Yeah. So that's odd. That's an odd function. Okay, but 18 is even and 17 is neither. Cool. And so this right here is just an example of an odd function. Use your calculator to determine whether the function is even, odd, or either by graphing. Okay, I guess. They gave you some random functions there. Let's see here. So we go to y equals, and we do the absolute value. So negative. We're going to go and do math. Numbers, that gives you the absolute value of x to the 5th power, good, right arrow, minus x to the 3rd power. Try it on your own. Plug it in your calculator. Is it even, odd, or neither? And then plus 6. Does it look like it's even, odd, or neither? What do you think? Wow, that looks pretty even. Doesn't that look pretty even? Yeah, because it reflects about the y-axis. Remember? So that one looks pretty even to me. And then when we graph the other one, which is b, let's give that one a try. You're going to have to do parentheses, you guys. So x to the 7th power, right arrow, plus 3x to the 4th power, right arrow, minus x, good. Close parentheses, then I'll divide it by 2. There we go. Okay, so you can see that that is not symmetric about the origin or about the y-axis. And so this one would be neither. Looking at the graph, that one would be neither. Again, the reason why it's neither. So the reason why it's neither is because if you try to flip that around the origin, right, that's not going to rotate very well. It's not going to, it looks like it, but it's not, because this point, and it's not actually a rotation. Yeah, it's 180 degrees, yeah. So this point will go down here, and this point will go up here. And so, yeah, so it'll bounce and do that thing. It's just, yeah, so that's neither. Okay, there we go. So last but not least, tell us something is algebraically even, odd, or neither, right? Even, odd, or neither, good. And then we have our ACTs. Which of the following numbers has the greatest value? What the? Well, that's 0.333 repeating, which, I mean, which one has the greatest value? I would think it's the one that has, I don't know, the one that has rounds up to the 0.4, I guess? Yeah. So the one that's 0.3333 repeating. Anyways, come back to that one in a second. You're right, Bart. Let's do 21. Okay, so 21 is 2x to the 4th power minus x squared plus 4. So how do we find it algebraically? Well, you plug in an f of the negative x. And you plug that in there. And wherever you see an x, you're going to plug in a negative. So we plug in a negative x here, shove it in there. Here, shove it in there. Right? So we get minus negative x all squared plus 4. So we shove the negative in there, and if we get the same function back, it's even. So we plug it in there, and so 2 times negative x times negative x times negative x times negative x to the 4th power. Negative negative is a positive. And then this is a negative negative is a positive. Good. So that's going to give us 2x to the positive 4th power, just like what we started with. What about the negative x squared? Well, negative x times negative x is a positive x squared. We still have the minus on the outside. Whoa, we get the same function back. And since we got the same function back, it means it's even. It means it's even. Well, how do we know if it's odd or not? So is it odd? Well, if it's odd, you go ahead and plug that in there, and you should get something a little different back. Okay, you should get something a little different. Again, I'm plugging in a negative x squared. I'm plugging in a negative x, and then we'll see what we get. So negative, 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 5 negatives is still negative, right? Because negative is positive, negative is positive, and then the negative changes at the end. So that's going to be a negative 3x to the 5th power minus, and then this is going to be negative times a negative is a positive x. Whoa! Is that the same as if we would have multiplied an x all the way through on the outside? Right? Well, if we multiply a negative through on the outside, let's see what happens. And so if you distribute that through, we get negative 3x to the 5th power plus x. Whoa! So that just changes all the signs. And if you just change all the signs algebraically, then it's odd. Then it's odd. Way-o. So we'll see if 20 is even or odd. You try it out. Is it even? Is it odd? Is it neither? If it, the signs don't stay the same and then it doesn't alternate, then it's probably neither. So give that a try. Okay, last one is we're talking about number 24 there. And so, yeah, which of these has the greatest value? I mean, you could go through and change them all to fractions, I guess. But the problem is 0.3, I don't think that really is a fraction, is it? Let me see. Change them all. And I don't even know if fractions even help you, right? So 0.33333, repeating, that's a lot of 3's. So what is that as a fraction? Oh, is 1/3 bigger than 3/10? That's the question. Well, 3/9 is 1/3, so that means it's bigger. Way-o. Yeah, so 0.33 repeating is going to be bigger than all those other ones, right? Because it's getting closer. It's getting closer and closer and closer to the next number that's above 0.333, right? It rounds up. Okay, you behind the screen, thanks for watching. Woo! Thanks for watching. Bye for now.